Course 3, you get to sweep today in math. I have never taught this lesson. This will be really interesting, but I think it's kind of fun. They have cool visuals to basically explain why the formula for lateral surface area of a cone is radius of the base times pi times the slant height. So to find the LSA, the lateral surface area of this part of a cone, just that part, so you can get the surface area of everything besides the base, you just need the radius of the bottom, pi, and the slant height. But I think it's important to understand the concept of what a sweep is. If you've got a broom, the width of the broom is like the width of the rectangular area you end up sweeping when you push along this way. That's how sweeping works, those of you who've never gotten to sweep the house. So that's the width of the broom. That determines the width of that area, right? The distance pushed is like the length of the rectangular area. So to find area of this rectangular swept portion, we're finding the width of the broom multiplied by the distance we've pushed, which is really just saying length times width, right? Okay, that's pretty simple when the broom just goes in one direction and the broom stays the same width. What if you kept this part of the broom stationary and you pivoted in a circular motion like this one? Then how would that factor into finding the area of this yellow portion, which will end up being, if you go all the way around, area of a circle? As radius CA, in this case, CA turns, it sweeps this circular area. Well, how wide is the broom if we imagine the radius as a broom? It's 5 centimeters. 5 centimeters, right? Radius, CA, broom. How far would point A travel if it makes it all the way around? Well, that's another way of saying what's the circumference. Remember, circumference is found diameter times pi, or 2r times pi. So the diameter, if it goes all the way across, is 10, right? So 10 pi centimeters, or 31 4/10 centimeters. How far does point C move as AC spins? Point C stays put. It does not move. It moves 0 centimeters, right? Because we're just turning from the outside in this case, like we were here. And do you understand how the very outside of the broom technically travels the furthest, right? It's traveling the longest path. And the closer you get inside of the broom, eventually you get to this spot where it doesn't travel anywhere. And each of these spots travels a little bit more as you get further out. Now, if you were to put all of these points together, that covers the full area, right? What if I asked you what's the average distance all of the points travel? How could we find that? We would find the longest distance, which is the same as circumference. We'd add it to the smallest distance, which is always going to be 0, because it's the center. So in this case, that's 10, the longest, plus 0. And to find average, you divide by the number of measures. 2, right? 1, 2. 10 plus 0 divided by 2 is the same as saying 10 divided by 2 is 5. Sorry, this should have been 10 pi. 10 pi. So this is 5 pi. Excuse me. So what's the average distance? I just found that is 5 pi. You take this plus this divided by 2. Excuse me. You'll probably need to be able to do that. The area of the circle we know how to find area of a circle. It's r squared times pi, but it would also be true to understand it as the product of the length of the broom, which is the radius, and the average distance the points of the broom move, which we just found. So if you actually take this times this, that's another way to understand the area of this circle or sweep. The answer is 25. Oh, sorry, I keep forgetting my pi sign. When I solve in terms of pi, it's easy to forget that it's still there. And that would also be the same as taking just radius squared times pi. But now we've understood it a little differently. We've understood it as the width of a broom traveling in a circle, multiplying by the average distance that all the points between C and A travel. And if you didn't follow, well, at least you'll know what they're talking about when you read this. You'll kind of have a sense of what you're supposed to respond with. And in the end, you're being asked, what's the area of a circle? Now at the top of page 750, they try to use the broom understanding, I guess, the broom approach to understand how we found LSA of a cylinder, which could be demonstrated as the label portion of a can. I think this explanation is a little bit hard to follow, and since you already know how to find LSA of a can, I don't think it's crucial that you follow all of this, but they're basically saying, what if your broom was a circle that traveled downward and just kind of covered all the points as it did that? You'd be sweeping with circumference. The length of the broom is the circumference here at the top. The distance the broom moves is the same as the height of the can. It helps us understand why is LSA circumference times height. But I don't know if that's easy to follow, and I think we already know that. The perimeter of the base times the height is lateral surface area, right? It's everything around the rolling edge. You could also think of it as sweeping with the height. So AB is your broom that travels all the way around. So you take the length of the broom, which is AB, or the height, times its traveling AB, the circumference. So it's just another way to understand why we find lateral surface area the way we do. And if you follow it at all, it's kind of interesting. But you should already know, if it asks you to find lateral surface area of a cylinder, you calculate perimeter of the base. So that's a circumference in this case. Perimeter of the base, and you just multiply that by height. Okay? Perimeter or circumference times height. Now, let's talk about the cone like I'd promised. What if we thought about lateral surface area, so everything but the base here, that surface area, as a sweep, where your broom is AB. It's a 4-inch slant height. Okay, so your broom is 4 inches long, and it's traveling in a circle where point A doesn't move, right? Point A stays stationary. It travels 0 inches as this part spins the greatest distance. What is that distance? It's the circumference of this circle. We find circumference by taking diameter, which is 2, times pi, inches. That's the length that B travels, the outside of the broom, so to speak. Okay? So you're just imagining that there's like sweepers on this bottom of this slant height, and this is the outside of the broom. Okay, now we multiply the length of the broom times, remember, the average of the distance of all the points on the broom. So that'd be 0 plus 2 pi, and then don't forget to divide by 2. That's easy to do. So this is really 2 plus 0 is 2. I'm just going to erase the 0. You don't probably ever really need to bother showing that part because it's obvious math. So we divide the 2's and get 1 pi. 4 times 1 pi inches is the LSA in this case. So we've just shown that surface area of a cone ends up being the length of the slant height times 0 always, plus the circumference divided by 2, which is that average distance the broom travels. That stands for average distance. We can use similar calculations to develop a even simpler formula. And we're developing the formula for lateral surface area of a cone. Circumference divided by 2, we said, times slant height, or L. Like we saw right here, the 2's end up canceling out if you have 2 pi r, which is, 2 r's diameter, so that works. Pi r times L. It all kind of ends up simplifying to surface area of a cone, lateral surface area of a cone, is pi r L when all said and done and simplified. I want you to imagine real quick before the end here that the broom, as it travels, is also getting narrower, which is impossible in real life, but it's helpful for the math demonstration. The broom is this wide at the beginning, and it keeps sweeping and getting smaller, so now we've got like this trapezoid shape. So we can use the broom understanding to calculate area here. What if we thought of this broom as getting smaller and smaller until it just reaches a point? All right, so what we've developed now is, okay, the broom started out this wide, and now what we've got is a triangle. Here, I'll start it from where I said it disappeared, so to speak. So if this is letter A in the lesson practice, if we found area of a triangle, understanding it as, that the broom started at 10, and the distance it travels from here to here is 5. All right, how could we use the sweep approach to think about calculating area of this triangle? Distance traveled doesn't change, so that's 5. And then the width of the broom is getting smaller and smaller. So what's the average width of the broom? 10 plus 0, because at this point it's 0, divided by 2. You multiply that. What we're really doing is we're taking the base divided by 2 times the height, which is just exactly how we find area of a triangle. So you get 5 times 5. The area of the triangle is 25. So the broom approach is even a useful way to think about the triangle area. But besides lateral surface area of a cone and maybe trapezoids, you probably won't think about sweeps very often from now on. And even for cones, you may just internalize lateral surface area of a cone is this, right? And you may never think about it as a sweep again. But this way you're ready in case it asks, what's the width of the broom? In a sweep of a cone's lateral surface area, that would be the slant height, right? Stuff like that. Feel free to contact if you're confused. These are the very last lessons, so we'll try to do our best to get our heads around this. We're within the last couple weeks of this book. Why don't you attempt practice? We just talked about A. I said how B is just use the old review on that, the way you've learned those before. Try B, C, and D. Okay, do your best.